Welcome back, and we're working on Algebra 2, Spring Semester Exam Review. These problems start at number 16, so I picked a few problems for us to work to give you a little bit of a help. So we're looking for the asymptotes for the following rational functions. So remember, a rational function means we have a fraction. We have two different kinds of asymptotes. We have our vertical asymptotes, which, remember, to find a vertical asymptote when we did our radii, we were looking for where the bottom is equal to 0. We also have horizontal asymptotes, which, remember, when we did our radii stuff, that was the part with the E, or our end behavior, and your teacher may have talked to you about Bobo Botten eats RC. And those are all acronyms to help us to remember how we can determine if we have a horizontal asymptote. Bobo stands for we have big on bottom. It will be y equals 0. B-O-B-O, Bobo. Botten means big on top, means we have none. No horizontal asymptotes. ERC, eats RC, is for exponents are the same. Eats. RC stands for it will be y equals the ratio of the coefficients. Eats RC. Now, our ratio of our coefficients, remember that's a ratio means a fraction, so it'll be y equals a number over a number. And what we're looking at when we're comparing these, whether it's big on bottom or big on top, we're looking at the degree of the polynomial, which, remember, the degree of the polynomial, we look at the exponent that's the largest, which in this case, the top exponent is a 2. The largest exponent on the top is a 2, so the degree would be a 2. The degree on the bottom, its largest exponent is also a 2, so its degree would also be a 2. So do you see that the degrees are the same, meaning the exponents are the same? Since our exponents are the same, our y equals, or our horizontal asymptote, will be y equals the ratio of the coefficients. Ratio meaning fraction. The coefficients are the numbers in front of those largest exponents, which in this case we have a 3, and this coefficient would be a 1. So it would be y equals 3 over 1. So our horizontal asymptote would be y equals 3. Our vertical asymptote, we said, is where we're going to set the bottom equal to 0. So we'll take our x squared minus 4, set it equal to 0. Remember, with a quadratic, we're going to factor and set them equal to 0. So when we factor, we'll have x and x. Factors of 4 will be 2 and 2 to get nothing in the middle or 0 in the middle. We'll have a plus and a minus. When we set each one of those equal to 0, and solve, that will give us x equals -2, and, sorry, that's ugly. There we go. Eraser's not going to do anything. There we go. +2 + 2, that will give us x is equal to 2. So we will have 2 vertical asymptotes and 1 horizontal asymptote. You can have multiple verticals. You can only have at most 1 horizontal. So that leaves you with a couple for you to try to find those vertical and horizontals. So next I will look at number 19. With number 19, we're just adding, which, remember, rules for addition, When we're adding fractions, we must have a common denominator. So when we look at our common denominators, we want to look at our factors. So the factors of x squared minus 4, we can factor that to be x plus 2 and x minus 2. So notice between my two denominators now, in order to get a common factor or a common denominator, I want that common denominator to be x plus 2 times x minus 2. Because notice this denominator has both of those, and this one has one of them. So I could make this denominator on the right-hand side the same by taking that right one and multiplying by a factor of 1, which in our case will be x minus 2 over x minus 2. So on the on the left, I didn't have to multiply anything. My denominator was already good, so my top will stay the same. On the right-hand side, my denominator needed to be multiplied by x minus 2, so I multiply the top by the same. Don't forget we must distribute. So that will give us 10x minus, 20. Okay? Once our denominators are the same, we know with addition, we work really hard to get that denominator, don't change it. And you can go ahead and leave them in their factored form. You don't need to multiply those out again. Now on the top, since I have several terms, I'm just going to collect my terms. So x plus 10x gives me 11x and a minus 20. If this factors, you could go ahead and factor it. It does not. Nothing will come out of 11 and 20. And so that would be my factored form. Okay, so that's your common denominators. You have, again, several problems that you can look at to practice and see how you do with those. Our next one talks about our exponential growth and decay. And you may have some problems that you'll see on your test where you just have to identify which one it is. So they're asking us, in this case, is it an exponential growth or is it an exponential decay? Remember a problem like this where you have time and population, notice it's going up to the right. When it's going up to the right, we know that will be a growth, exponential growth. If it's going down towards the right, getting close to that x-axis, that's going to be a decay. And that's all you would have to be able to do with those, is just to identify them on your semester exam. Now, the next one has us solving again, and we're going to be doing some solving with log problems. And our problem, notice it just has one log, so we did some of these in the last session. We could do the same type of thing, we just might have a different situation. In this case, I have an x for my base, and if I change it into an exponential, I'm going to raise it to this power, and that will be equal to this stuff, which that would be a negative 16. Notice they're not actually asking us to solve, they just want us to write it in exponential form. So this is written in exponential form. If they want us to go the other direction, if they want us to go the other direction and they gave you this, remember you're just going to go the other way. So let's just say I gave you something like x squared is equal to 25. I'll give you something you know is true so you can see it. So you would write that in log form by saying log base x raised to this, which would be 25, is equal to your exponent. And so that would be your log form. So you have from log to exponential and from exponential to log. Okay? Our next one has us evaluating. Remember, evaluate simply means find the answer. What is this equal to? For us, it's easier to work with equations. So if they want to know what this is equal to, we can simply say it's equal to x, and I want to go find x. Now we can turn it into an exponential again. So we're going to have a base 9 raised to the x power is equal to 27. Well, I can't raise 9 to any power to give me 27, but like in the problems we did before, we can make our two bases the same. because I know that 9 is equal to 3 squared, then that is going to be raised to the x. And I know that 27 is equal to 3 to the third power. So when I multiply my power raised to a power, that would be 3 to the 2x is equal to 3 to the 3. And when my bases are the same, then I know that my exponents must be equal as well. And when I solve, I would just divide both sides by 2 and get x is equal to 3 over 2. Which means log base 9 of 27 is equal to 3 over 2. And that's what they're looking for. Okay? We have more problems where they want us to express things as a single log, if it's possible. Remember, we're looking for our bases to be the same. These are all those properties that we learned of how we can put things together, or sometimes they ask us to compress them, sometimes they ask us to expand them. So we want to put these together. Since my bases are both the same, they're both 5, and it's being added, remember we use our rule with exponents that if we're multiplying with exponents, we know we add them. So since a log is the inverse of that, if we're adding, we know we're going to multiply. So this would become a single log of base 5, and all I'm going to be doing is multiplying x times this 2x. So in clean, simple form, it would be log base 5 is equal to 2x squared. And that would be my single log form. Okay? Same thing here. We know the opposite of subtract would be divide. So we know if we're dividing with exponents, we're going to subtract the exponents. So when we're doing logs, we're going to go the backwards direction. So my bases are the same. So I know I'm going to have log base 2. And then I'm going to be subtracting, or in this case, dividing 6x divided by 3. Which 6x divided by 3, I can clean that up a little bit. And I'll have log base 2 of 6x divided by 3 is 2x. And that would be my single log. Okay? If they want us to simplify simply means, much like evaluate, find what this is equal to. We don't have an x. We could set it equal to x. If we wanted to set it equal to x, that would be fine. Remember, when you have an exponent on a log, that comes up to the front, just like the properties that we learned. So that would become 2 log base 4 of 64. Well, if I want to find what log base 4 of 64 is equal to, sort of that evaluating that we did before, we could say 4 to what power is going to give me 64. You could maybe figure that out on your calculator if you wanted, or hopefully you know that 4 to the third is equal to 64, because 4 times 4 is 16, and 16 times 4 gives me 64. So therefore, since this is equal to 3, then that means that will be 2 times 3, or simply 6. Okay? If it's calculator portion of your test, you can take that and just plug it straight in and get 6. There's nothing wrong with doing that either. Okay? And lastly for this section, it's just talking about naming our parent functions. They just want us to write the parent functions. If it's linear, remember that's y equals x. If it's quadratic, that's y equals x squared. If it's absolute value, that's y equals the absolute value of x. A radical is y equals the square root of x. A rational is y equals 1 over x. Remember, rational meaning fraction. If you have exponential, that's y equals b for base raised to the x. You could put any letter in there that you wanted. We typically use a b for base. And our logarithmic is y equals log base b of x. So hopefully that helps you, and if you